Okay, hello, Integrated Science. This is Mr. B, and we are going to start our last section here. And this is called groups of stars. So again, focusing a lot on stars here, kind of out there, because they're the biggest kind of thing out there in our universe. So now we're going to look at, again, how stars can be possibly even grouped together. We looked at their characteristics, their life cycles they go through, and now we're going to see if they actually do exist, maybe more than one star. Again, they're not just solitary beings. Maybe they are groups of stars. Um, so first thing that gives an introduction there is there's a guy by the name of Giovanni Riccoli. He used a telescope like this one to observe a star in the handle of the Big Dipper. He discovered that he discovered two stars that actually orbit each other. So um, again, this is kind of a big, again, something we haven't really discussed. Again, we usually just think of our star being the sun. We have planets to orbit it, but actually there are in fact stars that orbit one another. Um, a group of stars that appear to form a pattern as seen from Earth is called a constellation. Again, there's a lot of things out there about constellations and zodiac symbols and things like that, so that might be something you've heard before. But again, and that's kind of just where they get most of their popularity for them. But the stars in a constellation are generally not actually close to one another. They just happen to lie in the same general direction of the sky as seen from Earth. So constellations aren't actually groups of stars, and they don't really orbit one another. It's just from our one view of Earth, they so appear to look that way. So that's why people, again, way back when, grouped them into what they see today. Um, so how are stars actually distributed in space? So astronomers have determined that more than half of all stars are actually members of what are called star systems. So where they actually are related to one another in some way, shape, or form. Again, most stars, again, they occur in groups of two or more, and that's known as a star system. It's again, a star system is just a group of two or more stars that are actually held together by gravity. So you definitely need to know that. Um, and when there's only two stars, it's called a binary star. Again, like a bicycle has two wheels. Again, a binary star is a star system that is just consisted of two stars, and the two stars will actually orbit each other. Um, and the reason we know this, and we do have some evidence that, is that sometimes the smaller star is actually too dim to be seen from Earth, or be seen easily from Earth, but it can still be detected based off the motion of the other star. Again, if we notice the other star is moving in a particular pattern, again, it can only really be explained by the fact that it's orbiting with another one. Um, if one star passes in front of the other, sometimes it will block some of the light from other reaching the Earth, and that's called an eclipsing binary star system there. Again, kind of like an eclipse. Again, the sun, moon, and Earth all line up. Again, light from the sun is blocked out, either on the moon or on Earth. Um, Again, sometimes light from one star will be blocked by the other star. That's called an eclipsing binary. Again, the brightness of eclipsing binary varies over time in a regular pattern. So again, we can notice that again, yep, here's a time where it's not very dim or it's not very bright. There must be something obstructing our view, and then nope, now all of a sudden it's bright again. So now it's not obstructing our view. So we can really kind of map those out about when those eclipsing binaries are going to be seen. But again, it's going to be different between each pair, but we can still kind of track those pairs and see when they're going through their eclipses. Um, then we have kind of to move beyond a binary where there's just two, we have star systems that are known as clusters. And there's three kind of clusters. We have open clusters, we have what are called associations, and we have what are called globular clusters. So the reason why we need to know about clusters is because studying them is useful due to the fact that all stars form together in the same nebula, so they're about the same age and the same distance from Earth. So when we look at a cluster, we know all those stars were formed together, so we know all those stars are about the same age, and we know they're about the same distance from Earth. So we plot the stars of a cluster on an HR diagram to estimate their cluster's age. So again, that's not saying that all of them were formed at the exact same time, but we can kind of give an idea by mapping them out to say, oh, yep, this cluster must be this old because they're falling at this part of the main sequence, or maybe they're not on the main sequence at all. So that can help us determine the age of different clusters, and again, to kind of give us an age of how old our universe actually is. So there's the Pleiades. This is an open star cluster that's visible to the naked eye right here. And then we have 47 Tucanae, or Tucanae, again, we'll have to look up that pronunciation. I probably just butchered that there, is a spectacular globular cluster that is visible in southern skies. Again, this is a globular cluster here, and this is more of an open star cluster. As we can see, globular is much more condensed. Open, they're much more spread apart. Um, Again, I think we'll get definitions there here in a moment. So yeah, so open clusters, like again, the one they just saw there, they have disorganized or loose appearance, and they contain no more than a few thousand stars that are well spread out. They often, excuse me, will also contain bright supergiants and gas and dust clouds. Um, so that's just, again, you can see that in that picture. It's a pretty accurate description of that definition there. Again, you can see over here, again, tried to point with my finger, not the mouse. These stars are much more spread out. Again, there's still a good amount of stars, again, but they are much more spread out. Then we have associations. And an association is a temporary grouping of bright young stars. In time, a gravity from nearby star will break these groups apart, and they will go to form their own clusters. Again, associations are typically larger than open clusters. Again, and that makes sense. Again, the farther something is apart, the less strong or the less strength the force of gravity actually has to hold them together. So associations, because they're so far apart, they can be broken apart by gravity from nearby stars, and maybe they'll go join another open cluster or possibly a globular cluster. Globular clusters are large groups of older stars, and they usually lack sufficient amounts of gas and dust to form new stars. They're spherical. They have a dense concentration of stars in the center, which again spherical, kind of a circular shape. Again, these are older stars, kind of formed to the center. Again, no really new stars going on there in the globular clusters. Some globular clusters can, in fact, contain more than 1,000,000 stars compared to thousands in the open clusters. They usually do not have short-lived blue stars because these stars have already died out. And astronomers estimate that the oldest globular clusters are about 12 billion years old. Again, billion with a B there. Thus, the universe must be at least that old. So, again, there are some globular clusters. Again, they probably have those smaller red stars. Again, not burning as hotly, but they're going to last for much longer. Again, forming these globular clusters. So, I believe, yep, that is it for this video. Let me know if you have any questions.